and we'll have both of the talks separated. Um, Hopefully that's how it works. I'm not sure if that's exactly what's going to happen. So I will share my screen now. Okay, you guys can see my screen and everything?
Indeed.
Perfect. Okay, so I'll be talking about building and bettering machine learning products. And so this will be a very general talk. We don't really have enough time to get into the nitty-gritty of all of the different details. And this isn't necessarily a comprehensive guide of like, this is all of the steps you need to go through in order to have a successful product, but it is just a general checklist of some of the things that I think through while I'm building the various different projects that I've worked on. So to start off, things to consider, this is a general outline of all of the different things that we'll be discussing. So you have to define a business objective. So what do you actually want to do? And then you have to define what your actual data science problem is. And sometimes that's overlapping with the business objective, but very often you have to kind of dig in and figure out what the details of that are. And then you have to figure out what your definition of success is. You need to find the right data. You need to prototype a solution, and you need to figure out how you're going to deploy it, what setting it's going to be put in, and what constraints you have there. And then you need to put in the work to package and deploy it. And then you can iterate and improve and expand on what you already have. And then you have to monitor it and make sure it's working correctly. So for the first step, defining the business objective, this is the piece that you typically start with. If you're working in a company, someone comes to you with a request. So something like, right now I'm working with Kimberly-Clark, and they're saying, we want to reduce fires in our mills by 50% next year. So they had a few fires in their mills, and they say, that's obviously not good. Let's figure out how we can reduce that by looking at some sensor data and raising some flags before those happen and cause a bunch of damage. And so this kind of falls in just normal requests from business users. This isn't going to be something where they come and they say, oh, I need you to get an AUC of 0.9 and do all of these different things. It's just a direct business goal to reduce some costs or to increase efficiency or to save some time. It's typically abstract, and then we have to do the work as data scientists in order to translate that into something that we can actionably change, either by creating a model or doing something else. So examples of that, the one about the fires in the mills, our employees are spending a lot of time on task X. Can machine learning help automate? That's something you'll frequently get is there's some time suck and they say, can we do this automatically with machine learning? Or another common one is we have a whole bunch of data, what do we do with this? Obviously, there's some value to it. Everyone keeps claiming that data is the new oil or the new gold or whatever they want to compare it to. And so people have this idea that data will somehow magically turn into value. And so that's sometimes passed on to data scientists as they say, we have this data, how do you make value out of it? In my experience, that's not typically what leads to the most success. The best success typically comes from the business directly asking questions and laying out goals. I would kind of shy away from if someone gives you a request and says, here's data, make value out of it. You have to be skeptical and start asking questions early on. And so in that process, you have to figure out as many details as possible. So in the fire example, what's the cost of a fire? So how much exact economic damage is being caused by a fire? So is it $2 million, $5 million? What is the cost related with that? And what is the cost of the alternative? So if the model functions correctly and it eliminates all fires, how much money will you save the company? And what happens if you start having false positives? So your system says a fire is about to occur, so they take emergency action and they cause some harm. And so, for example, let's say they have to pause production for 30 minutes or something like that. what exactly does that mean in terms of cost? How much did they reduce their throughput in terms of paper they can make? And there can be all kinds of different scenarios with that. So for example, maybe they can't just pause production. Maybe they actually have to do some fire suppression thing that just ruins all of the paper product currently in their pipeline. And so it can have an even greater cost than the fire, for example. You have to measure all of that stuff out and examine exactly what the implications are. And so on the right hand side, I have the SMART goals, the stuff that you learn in business school about laying out specific, measurable, attainable, relevant, and time-based goals. You can expect something like that, but from a business user, but it's not necessarily going to be a reasonable data science goal. So we'll talk about that on the next slide. So they give you this goal, and then you have to turn it into an actual plan. So they say they want to reduce fires by 50%. Well, a simple way to do that is just to say, shut down the plant. All of the fires are gone if you just don't use the plant. But that's obviously not what they want. So you have to start putting additional constraints on it. So you might infer, okay, we can reduce fire by 50%, but we can't have more than 2% downtime or something like that. So you have to ask more questions because they're not going to give you exactly what they mean on the first try. It's pretty difficult to be that specific, even as a business user, when you know what people are going to be doing with that information down the line. So it's a collaborative effort. You have to have that conversation back and forth and make sure that you're seeing eye to eye in terms of what they want and what you can deliver and what the best way is to approach that. And so pretty often with these projects, there's lots of different ways to achieve that goal. And something I really would like to caution people about is not every problem is a machine learning problem. Very often it can be something that's solved with a Python script or some other method. So for example, in the fire case, if they have this multi-million-dollar system already and it has some built-in diagnostics and it can already give you some sort of warning of when a fire might occur, and right now they're just ignoring it, maybe the correct action is just to act on that warning. And so it could be a simple Python script that says, hey, the machine says it's overheating, time to turn off for 30 minutes. And just adding that logic can provide massive value. And there's no need for an additional machine learning model there. That's something that I just want to throw out there, that there's a lot of times where machine learning is just not the answer. You can do simple things that also create value too. And along that line, there's alternate approaches. So you might not want a machine learning model, but you might want some sort of a report. So if you could do a report for, in this case, we have 18 fires worth of data. If we could look at the 18 fires worth of data and see what the conditions are that led to that fire, that might be just as valuable as a model that actually tells you, hey, stop production when XYZ, because maybe the analytics report could give them some insight to say, hey, we just need a better air conditioning system, or we need a better system to clear out the particles that are accumulating in the air. And that could be better than actually a machine learning model that would just give them warnings 15 minutes beforehand, but they didn't have anything actionable to do with that warning. And so once you have that defined, how exactly you want to achieve that goal, and once you add constraints, you also have to start um, figuring out what metrics are associated with that goal that you're working towards. So they might say reduce fires by 50%, but then you have to start figuring out in terms of, do you want log loss? Do you want AUC? Do you want RMSE? If you do want a machine learning model, you have to figure out exactly what you're trying to optimize for. And then defining success and quantifying the benefits, you have to look at what is the actual upside of a successful project. So who does it benefit? Does it save people time? Does it improve upon previous methods? Does it open new possibilities? I would say that there's kind of 4 different ways that a machine learning model can be useful. So one of them is that you scale things up. So you used to have someone who manually labels some process, and then once you replace them with a machine learning model, you can do tens of thousands of things or something like that. Or you do it as a time saver. So it used to take hours to do, and now it can take minutes. Or it's doing something more accurately than it previously was. So you have a human labeler and they do 90% accurate, but if you get a whole bunch of labels, you can beat their inconsistent performance. And then the other thing is opening new possibilities. So can you actually do something that you couldn't previously do? And that can come from scale or complexity or any number of things where beforehand it just wasn't feasible. So one of those things, that this picture that I have to the right is from my old company that I worked at. We were working on building systems, like physical buildings, and we were looking at their blueprints. And so one of the things that we had a team doing was they were looking across a building and labeling all of the different assets. So all of these bounding boxes are labeling lighting fixtures, for example. And so originally we would have a team that would go through and they would just label, okay, this is lighting fixture 22, 22, 22, 22, and 28A, for example. And they would go floor by floor, room by room, and tally up all the different stuff in all the different rooms. Um, and this is such an exceptionally time-consuming process. If you're doing it in a Las Vegas casino, for example, there's just so many assets that it's not even possible to really label all of that. And so trying to apply a machine learning method makes it so it's scalable, and it's also possible to label more things than you previously did. So before, you might not have labeled all of the lighting fixtures, but you might have labeled all of the elevators or various other high value assets. And this allows you to do just everything. But then on the flip side of that, you also have to consider what the downsides are. So will it potentially hurt someone else? So in this scenario, um, you can see that this model is not perfect. It's missing the 15E, and it's missing some of these 28As. So you have to think, originally a labeler was doing this and they would just go from scratch through the whole page. Um, and now the way we were developing it, it was sort of a hybrid approach where the model would take the first pass and then the human labeler would actually take the second pass and make corrections and try to fix some labels and stuff like that. But looking through what was actually happening there, it would take even longer for the human labelers to go through and correct all of the errors than if they just started from scratch. So this was a project that was eventually canned because we realized that the negatives outweighed the upside. Because regardless of how good your accuracy was, if it was 99%, it wasn't, the model was never going to converge to perfection. And if a human labeler was always going to need to intervene, then it was just a waste of time, because it's very difficult for a human labeler to go through and correct a document that's already been labeled. It's more difficult than if it just didn't have any markings to start off with. Um, and so that's something that you have to consider. What is the worst possible outcome when you're deploying a model? So last week we talked about self-driving cars, and so obviously the worst possible outcome there is you wreck the car and you die. And so that's pretty extreme, but that's something that you have to keep in mind for all of the different systems that you're deploying. Does it have the potential to do more harm than good? You just have to weigh that into consideration and take into account how long you think, how often you think the worst possible outcome is, and what the actual implication of that is. And then on top of that, you have to lay out some criteria for what a success is. So you can't just continue on forever and keep grabbing 1%, 1%, 1% gains on a model when it doesn't necessarily improve anything. So you have to um, figure out what the end state is. So once you've defined all of those goals, you have to search for data and you have to figure out what is relevant, what is required to actually do what you're trying to do. And you have to look, is it something that we already have a hold of? Is it something that we have in our company databases? Is it commercially available? Can we just purchase something that might be useful to us? Is it something that we can scrape easily off the internet? And so one of the good data sources for that is Kaggle, and then there's also Google Datasets. And I default to Kaggle at this point. So I look on their data sets and I see if there's anything relevant to what I'm working on. So going back to that sort of building use case, one of the things that we were looking at was, can we use Bluetooth beacons in order to localize where someone is inside of a building? And so originally the problem would have been, okay, we have to buy some Bluetooth beacons, we have to set them up all around our building, we have to track our own employees and figure out where they are. And that's a difficult task. It takes a lot of startup cost, basically. And so what I did is I looked on Kaggle and I said, are there any data sets already existing for Bluetooth beacons? And it turns out there was. There was this data set that was from this research lab where they basically set up a bunch of Bluetooth beacons in their library, and then they tracked people's phones using those Bluetooth beacons, and then they were able to localize where they were. And so I built this simple prototype showing um, we have some data. It's proven that we can actually do this project. And so that was a good way of at least making a prototype and proving that we can make a prediction given the data that we already had available. So after that, you have to prototype a solution. So the example I always use is the Oculus Rift. I don't know if you guys know the story behind him, but there was this young guy, Palmer Luckey, and he was 17, and he built out the original prototype of the Oculus Rift, the popular VR headset now. And he did it from just very basic parts, that stuff that you can see on the right. It's just kind of a phone display taped together with a ski goggle mask, and he just really jury rigged it up. And I think that that's the attitude that you should have in these early stages, is just prove the various pieces work and just string them together and then improve after that. But the first part is just making sure that the concept makes sense and that you can make it work. And then after that, you can make it nice and cohesive. But to start, you just have to get the constituent parts and then string them together in any way possible. So for us in the data science field, that starts with just how do you load the data? How do you pre-process the data? So very often you might be grabbing it from a database or a random CSV, or you're taking in video or audio or text or any number of different things, and you have to figure out um, how do you just grab it and load it in pandas or something familiar, and how do you format it in a way that is useful for a machine learning model. And then after that, you have to define what the output of that model is going to do. So for example, in the fire case, do you have that model directly take action and trigger something, or do you just have it as a signal that the operator uses? And are you going to make it just have a real-time signal, or are you going to have it predict 60 minutes in the future so it gives you foresight into what might happen in 60 minutes? There's lots of different ways that you can cut that up, and you have to figure out exactly how you want to structure that. And then once you get through the initial data loading portion and the details of your model, what I typically do is I just go all out on the modeling, and I say, can I get this model to an acceptable performance? So if you have text, you might pull out BERT. If you have images, you might pull out some ResNet or something like that. You just want to prove that you can at least predict the thing that you're trying to predict. So on the fire suppression problem that I'm working on, we have all of these rows and we only have a few instances of fire. And so the first step is to prove, can we even predict this? Because it's actually fairly difficult. Because if we can't predict it, then we don't have to build a a full product around it because the product's already dead. So you have to prove that you can get to a sufficient level of performance first before you build the rest of the product around it. And then once you prove that, once you've gotten to the point that you know you get acceptable performance, then you have to start taking some of the constraints into mind. So how often are you doing predictions potentially? Are you doing it real time? So a good example of that is the stuff on everyone's phone in terms of like autocomplete and the Google email assistant stuff where it will automatically fill in some text for you. That's not useful if it doesn't fill it within a quarter of a second or something like that, because you're already typing in your result and you've probably already passed it. If it takes a minute for it to load, it's not useful. There's lots of different scenarios where you need basically real-time results. So when you're doing credit card fraud detection and stuff like that, someone swipes their credit card, they don't expect to sit there for the next 15 minutes while you crunch the numbers and send stuff over the network and all of that. So there are lots of scenarios where real time is kind of the constraint and you need something that's exceptionally fast. But there's also scenarios, for example, in the fire case, where you might have something that you're just running every minute. It doesn't have to be continuously running. You don't have new batches coming up. It's just a scheduled thing that you might run every minute. Or you might have something that you run every night. So you prepare a um, leads report for your sales team, for example, and you run that every night and they get into the office and then they're ready with all of their highest scoring leads. That's another area that you can go down. Or you can go even coarser than that and it's just something that runs once a week, for example. There's all different kind of latency constraints there. Um, and then on top of that, you have to take into account the compute constraints. So do you have access to a TPU, a GPU, CPU? Where do you imagine deploying it? Is it going to be on a phone? Is it going to be on someone's desktop? Is it going to be something where they just interact with it through the cloud so you really don't have any constraints there? It just depends on the scenario. So that's something else that you have to keep in mind, because if you build this massive model and then it has to in some way be miniaturized, that might be very difficult. And then another consideration is if your model has to be periodically retrained. So sometimes you have new data that comes in, and then as the landscape of thing changes, you have to keep it up to date or else the model will eventually degrade. And that happens across almost every field. So if you have some computer vision thing and all of a sudden everyone's writing hoverboards around campus and it doesn't understand what those are, you have to retrain it in order to update those. So it might be something that happens over a longer time scale than, for example, the stock market where things are constantly shifting, but there is almost always going to be some shift in what you're looking for. And then once you get all of that out of the way, you have to actually package it and deploy it. And this can come in many different forms. So once you figure out your constraints, you have to potentially shrink down that massive model that you use to prove the value with down to something manageable for your deployment scenario. So maybe that means removing certain free features, or maybe that means using a smaller model. Maybe that means using a different library that's a little bit faster or lightweight. There's lots of different things that can happen there. And there's also lots of different ways that you can deploy something. So what I've seen very common is people packaging up their model inside of an API. So they might use Flask or Django, and they put it on Amazon Web Services, Elastic Beanstalk, and then basically a website or an app or something else will make a request to their API and then give them back a prediction. That's one of the most common use cases. But another one is something where they do batch scoring. So like in the example with leads that I mentioned earlier, you might have a new set of leads every week or day. for example, and you just have to run it every night. And so you can pretty easily automate that with something like a cron job, which is just a built-in thing within Linux that allows you to run scheduled tasks, basically. Or you might have Jenkins or some other system that allows you to schedule that and orchestrate it across separate systems. There's lots of different ways to do that. We don't have time to get in the nitty-gritty details of that. And then the other approach is directly packaging it in the app. So if you have either a phone app or a website or something along those lines, it might be the case that internet access is not always expected, or you just have something small enough that you think that it would be faster to do it directly on the device rather than sending out an API request. There's various different ways that you can bundle that into the devices. So there's TensorFlow.js, which is a JavaScript library that allows you to bundle it into a website potentially. The thing to keep in mind there is if you have a model that is 50 megabytes, for example, every time someone loads your website, they're going to have to also be sent your full model. So you have to make sure that it's a scenario where your model is still fairly lightweight, but it's something that can be computed on the user's end rather than going back to a server and needing to compute there. And so in terms of mobile devices and embedded devices and stuff like that, there's the option of TensorFlow Lite, which is basically a way of taking an existing TensorFlow model, doing some quantization and various other tricks to make it as small and as compute efficient as possible. And that's not something I've necessarily used very much. I'm going through a TinyML book right now that's talking about pushing models to embedded devices. But that's something I'm still learning about, and it's fairly new. Um, that's I would say most people haven't interacted with that yet because it's so new. And then the last thing about deployment is you have to define what the failure behavior is. So what happens if someone doesn't have internet access? What happens if the job fails? What happens um, if bad inputs are given to the model? You have to look through all of that stuff, because if it just crashes the app, that's obviously catastrophic. Um, but there's lots of other ways where that can go wrong as well. For example, it might just give bad outputs. It might tell you the wrong thing. There's lots of different things that can go wrong there. And then after that, once you've got everything finally packaged and deployed, you want to potentially iterate. But first you have to figure out, is it even worth iterating? So is there somewhere that you can provide additional value? So in some scenarios, a better model is very useful. So if you're trying to predict the stock market, as accurate as possible is what you're going for. But there's many scenarios where if you get beyond 90% accuracy and you're only making a few errors here and there, the users aren't going to complain, and squeezing out an additional few percentage points doesn't really matter. So maybe it's not worth your time to continue iterating on that. Maybe it's better to just pause and work on a different project or work on a different area than just the modeling. And so one of the things in that equation is, as you get more users, as you get more requests, it might become the case that your response time starts increasing. So you've got a bunch of API requests and they're backing up. Um, or you're just accumulating a whole bunch of cost because you set up some sort of load balancer and it spins up more AWS systems and it starts causing you problems there where you're just building up a whole bunch of server costs. Then you might want to spend more time looking on, is there a way that we can streamline this and make the model more efficient, either in terms of pre-processing or the actual model itself? And then you could save money there. And maybe that's more useful than actually building a better model, is just making a smaller model that gets the same performance. And then the other area to look at is maybe there's some alternate format that gives more value. So in the case of the fires, one of the original ways that they originally posed it was just binary classification. Is there going to be a fire or not? Um, but there's also the possibility of a regression target saying basically how far away are we from a fire, and or there's all kinds of different ways that you can pose that. So you might want to look, is there some value to predicting further back in the future? So right now, the way that the targets are connected, it might be just saying exactly the minute where the fire occurred, but there might be value in saying it's 15 minutes before a fire. There's lots of different ways that you can cut up almost any problem. So you might want to look into, is there some alternate format that can give more value? And then as you're iterating, if you do choose that a better model is the way forward, then you want to focus on error analysis. So looking at which samples the model's getting wrong. So sometimes you look at this and you get some obvious insight and you can say, oh, every time it got it wrong, it was because this value was over 200, or it only got examples wrong where this field was missing, for example. And so sometimes there's obvious gains that can be had there, um, and sometimes there's not. Sometimes it's a matter of figuring out some um, clever feature engineering trick or some more complicated model, but sometimes you can get easy gains just from error analysis. So it's valuable to look at exactly what you're getting wrong. And then the other thing is maybe within your model, you've built up some knowledge that you didn't previously have. So your model is able to um, predict something, but it also has captured some understanding of the paper mill, for example. And then using that knowledge, you can also predict other things. So it might be possible to take those pre-trained weights that learned about the paper mill and apply them to some other problem. And so that's an interesting way of looking at that and extending it and saying maybe we can do something additional on top of this. And then the last step is monitoring. So just putting in some sanity checks and making sure that things aren't getting out of whack. So the first thing you typically want to check for is, are the inputs to your model changing over time? So going back to the paper mill case, you might see it that a fan is just slowly degrading over time. So its RPM just keeps going lower and lower and lower. Or you see a temperature just keeps getting higher over time. And those are the kinds of things that you need to actually inspect. So that might be a problem, or that might not be a problem. That might be expected behavior, and they're going to replace it in 5 years, but you don't have a long enough context to understand that. So you have to look at that and you have to say, is this drift expected? Is it unexpected? Is it something that's going to screw up my model? You have to measure out all of that stuff. And then you also have to look at, are the outputs of your model changing over time? So is it the case that you're giving way more false positives now? Are you always saying that there's a fire? Are you saying that there's never going to be a fire? Um, you have to inspect that and see what the distribution is. And if there's a reason to explain it, or if there's not a reason to explain it, you have to actively be looking at that and make sure that it's making sense and adding up, because there's plenty of things that can just go completely haywire. So for example, there's some field in your database that your model used, and the database administrator decided to rename it to something else. And so every single time it's missing now, and it used to be one of your most important features. There's tons of things that can go wrong there. So you just have to continue to sanity check and look at all of the different factors there. One of the things I mentioned on a previous slide is response time getting worse. Maybe you can just throw more servers at it. Maybe something has gone wrong in the pipeline. So maybe you've got some background process, or now you're sharing a server with someone else. There's lots of different things there, because in a lot of these applications, response time is actually fairly important. In some, it's not, but if you do see fading response times, then you probably want to inspect that. And then the last step is just sort of qualitatively making sure that your users are still happy with the output. That can mean lots of different things. If it's internal to your company, you might just go talk to whoever's using the tool and saying, hey, is this still being useful? Does it have to be updated? Um, because people are not always the best at updating you and saying, hey, it looks like this thing is broken. It's been giving me blank leads for the past 2 weeks or something like that. And once you get that update, maybe you can actually go back in and fix things. But you have to be proactive in making sure that people are giving you those updates. And then another step is actually inspecting the outcomes yourself. So you look at the inputs to the model and you just say, for example, if it's an image and it classifies it as a cat, was it actually a cat? Just taking that manual approach is pretty useful very often to make sure that you're not giving nonsense results for whatever reason. And that's it. So we can open up for questions if anyone has any.
Yeah, I have one. This is Anne. So
Sure.
part of you've got an entire process there, and I've been part of large projects where it's dealing with the customer, but I often run into I have to go through my manager, or I don't have direct contact with the customer. There are additional wickets that I have to go through, etc. So I wondered if that was the case for you. You mentioned a direct contact with checking up with the customer, so maybe you don't have that issue, but if you could address communication and the impact that that has with the customer.
Yeah, that's a massive issue internal to almost every company, and also when you're interacting with other people too. So everyone holds their data pretty closely, and sometimes it can take a very long time just to say, can I get access to this? It might take weeks just to get access to a database or a field that you want, or the correct credentials to their VPN, or there's a lot of stumbling blocks there. Um, Recently, I haven't had terrible issues with that, but it is definitely something that slows a lot of projects down.
Do you have any issues with the new California data security law?
I haven't personally dealt with those. Typically, with what I've worked with, it hasn't been personal data. So, like with the fire case, I'm not taking anyone's personal information. Um, that was actually a big issue in the recent deepfake competition that popped up. There was just a controversial ruling on that because they disqualified the first place team because they used an external data set that had a commercial license, but they didn't have the written consent of all of the people inside of that data set. So that is something that is an active issue, but we don't, I personally haven't had to deal with it very much.
I had a question. So it seems like this is obviously an iterative process, but I guess when is the stopping point? If it almost seems like the goal keeps changing, or not the goal keeps changing, but the goal is defined, but like the data keeps changing. When do you stop iterating and be like, this is the product, or is that something that goes on forever?
I think that it's something that you can, it has kind of different levels of development. So you started and you say, okay, here's the prototyping phase, here's the deployment phase, and then beyond that, you just say that I'm just monitoring this. And you get to that monitoring phase when you say this is acceptable for performance. We're not really going to get very much out of this. Maybe we can improve it in some minor way, but it's not going to change the results entirely. Um, and that was one of the things I had on an earlier slide, was basically you need to define what the end point is, because you can continue iterating on this forever potentially until you get the absolute perfect result. But in most projects, you can get to decent performance and just call it done, because very often you're not going to get more material out of it.
as a follow-on to that, you have the main project that you're doing, which is the machine learning system. Is it common for the industry to have maintenance contracts that extend throughout an extended period of time?
I can speak to what we do at H2O. I don't know how widely this is applied though. So the way we do it at H2O is you have a license to driverless, and then included in that driverless license is a whole bunch of support. And once you no longer pay for support or a license, then you're kind of on your own. And but in that support, we do a whole bunch of stuff in terms of monitoring and making sure all of their stuff is healthy. So in that sense, we do sort of offer support and monitoring and that end of project care. Um, but I don't know how often that is. I don't think a ton of people. I don't know that a ton of companies have that. If they just have like an internal data science team, they might. I don't think they really have like contractors that are just focused on maintenance necessarily. But that would there's mixes from all of the different teams. So you might be having interactions between the software engineers and the data scientists and the DevOps team. And so that might be something that falls on the DevOps to kind of do that end of life maintenance stuff.
Hey Ryan, there's this step that I often run into at my company where we'll have a problem, we'll define it, we'll start to take a look at the data, and we'll say, yeah, we think we can take on this is an interesting problem. We think we can take this on. Maybe we're trying to predict whether somebody has a particular disease. Maybe we're trying to predict whether somebody who has an appointment with a doc, whether they're going to keep that appointment or they'll cancel it. And then a lot of times, as we really get into it, it's like, wow, this is really hard. I don't know if we're going to be able to make a prediction that's good enough or whatever. And so I don't know if you have anything to say about that. Like, I mean, for us, I feel like we're generally doing the right thing in sort of the initial analysis, but I don't know if maybe we're not doing enough because we are running into times where we think we should proceed, but at the end of the day, we just don't end up with a model that's good enough.
I think that's in one of the steps. I was saying basically you just in the prototyping phase, you just do an all-out model and you just say, is this even possible? And if it's possible, like no holds barred, just full custom model, doing as much feature engineering as you possibly can, and you still don't get good performance, then that's the point to just kill the project, because you cannot model it to a sufficient level of accuracy. And that's why I advocate for doing that significantly before you start building the whole project around it. Just at least prove the data can predict what you're trying to predict.
Can I ask, when you talk about this no holds barred model, I mean, how much of a time investment might you put into that?
It depends on the complexity of the problem, because there are many things that I feel like I could probably get a prototype that is what I would consider basically no holds barred modeling within a day or a week. But if it's some very complex task that's never been approached before, then it's an entirely different thing. So like all of the binary classification stuff and stuff with images, and that stuff is pretty well documented. You can basically copy and paste from an existing tutorial and you'll have probably 95% of what you'll ever achieve anyways. But there's different things where you have to get much more creative and figure out how to handle the data, and how do you even pose the target that you're trying to predict, and stuff like that, where it might take more, it might take a month. But that would be kind of where I cap it at.
Cool, thanks.
All right, if we have no more questions, then we'll wrap it up for the day. For anyone interested, we'll be talking about Kaggle stuff, looking at the multilingual toxic comment challenge. We'll do that in another 15 minutes, I guess, so 2:30, so we can take a snack break and come back for anyone interested in that. Another side note, we're also doing the future engineering book. We'll be starting that in another 2 weeks on the 27th. So anyone interested in that, we've also got book club starting in another 2 weeks. I'm trying to think what else. And next week we also have talks from Ingrid and Chris. I don't have the details for both of those up, but we'll have 2 more talks next week.
Thanks for the talk, Ryan.
Yeah, no problem.
Awesome.
Great talks, both. Thank you a lot.